CloudDB, shaping your new normal.
Welcome everyone to the 2021 APAC Groundbreakers Virtual Tour. This year, our event will be the biggest one ever done with 144 sessions, including normal sessions, workshops, and hands-on labs from 100 different speakers over 17 days. Also, it will cover sessions in 4 different languages. Please remember to register to as many sessions as you can. I would like to say thanks to all Oracle user groups and Java user groups that made this event possible, and also to our sponsors, Oracle Groundbreakers, and our main sponsor, CloudDB. Now for today's session, Graph Features for Oracle Database by Ryota Yamanaka and Dominik Junkermann. Please feel free to write questions at any time during the session by using the chat tab of live webinar, and the speakers will be answered them as soon as they can. If there are any issues during the presentation, please feel free to contact me at any time by using the same chat at live webinar in the bottom right corner of your screen, and I will try to help you the best I can. Now, without any more delays, I would like to leave you with this amazing session by Ryota Yamanaka and Dominik Junkermann. Ryota, this session is all with you.
Thank you, Francisco. This session is actually about the one use case of the graph database, which is about data lineage management system, and presented by an Oracle customer, Kagura. But before starting the use case session by Dominik, let me do a 5-minute recap about graph feature. I'm a product manager from Oracle Product Development, Ryota Yamanaka, based in Japan. So when we talk about graph feature, it is often called as property graph structure as well. Property graph model is a format to structure data as a graph. So we can have nodes, or we can also call them vertices and edges, and each vertex and edge can have a arbitrary set of properties, right? And with this property graph data, we can have a graph database to hold such graph data, so that we can run graph-based query as well as graph algorithms on top of those graphs. So one feature is that we can use this kind of graph-based query. We have PGQL syntax in Oracle, and other graph-based queries such as Cypher, Gremlin, they are getting more and more popular. So these are the examples of graph-based queries. We can have this from much clause to express the structure of the graph, like a subgraph pattern. So in this case, M is a node and P is another node, and M and P are linked by a relationship called likes. So one person M likes another person, and this M person is, his name is Mario, something like this. Also, Oracle Graph has this, well, more than 60 built-in graph algorithms, such as or page rank, or shortest path finding using Dijkstra algorithms, so that we can easily calculate the graph-based scores using these algorithms. Also, graph feature of Oracle database has this graph visualization component. So we can deploy this application on graph server, so that you can visualize the graph according to the graph query because our Oracle Graph has Python API and Java API, so that we can integrate those API with notebooks such as Peppering or Jupyter, so that the data analytics people can run graph queries and algorithms on top of these notebooks. So this is the architecture, whole architecture of the Oracle Graph. We can run PGQL queries against Oracle database, as well as an independent graph server for extreme performance. And these graph server and Oracle database can support Java API. So we can use the built-in graph visualization component GraphViz, but at the same time, many of our partners are developing their own visualization, their own analysis tool on top of graph server and Oracle database using Java and Python API. So the data lineage management system, Dominik is going to one of the such a custom visualization tool on top of Oracle database. So I hope we can discuss the overview of the graph of the system, as well as to see the impressive demo. So can I hand over to Dominik now? Take my screen.
Yes, I'll change to my screen. Okay. Hello, my name is Dominik Junkermann. I'm working here at Kaggle, and today I would like to introduce you to our system called Trinity, or Trinity, if you say it a bit faster. Trinity is, the name is made up of two words, first Trinity and second Lineage. Trinity because it represents the three aspects of our system that we want users to be able to use, being analytics, the management, and then the visualization. Management and visualization of the data that the users have uploaded and that is handled within the system. Lineage, we added in the name to represent the change over time, the evolution of the data within the system, going from one version to the next, and using the visualization to see where the data comes from, which I will also show later in the demo. The system Trinity itself is made up of a core and wrappers. The core is built in a way so that it can be universally used for any initiation or instance of the system, so that it's built agnostically. So it doesn't matter what data and what subtypes have been created, while the wrapper is built specifically for each customer, which means that it might have different UI, different API parts, which are not included in the core. Because the wrapper is customer specific and contains customer specific information, I can't show any wrappers since they have confidential information. So I'll be showing an example of the core today. The general structure of the core on top of the Oracle Cloud is being the Trinity core itself, containing the core UI, the core screens, Node API and Java API, also Oracle database and an object storage. The Java API is used for communication between the Node API and interaction with the graph data. As Ryota said before, that is so that we can make PGQL requests and use graph data for the visualization. The Node API itself contains all the general functionalities that Trinity provides and which are used within the UI. Since Trinity manages and visualizes data uploaded by the user. We also have an object storage, which stores all the files and the reports, which I will come later to. And the database itself also has the user data for local logins and for session information. This is in the core. If the user or the customer wants a different login way of logging in, they can SSO, then of course that's would be handled within the wrapper. And the Oracle database also has the type schema, which I will be also talking about soon. The graph data itself inside the core, we try to keep as simple as possible so that it's can stay agnostic to the data that it uses. So we only have basically two node types, being the dataset node and the data node. And the easiest way to understand in what way we use it is if you think about a file system, then the dataset nodes would be the directories, the folders, and the data nodes would be the files themselves. So the dataset nodes are basically just nodes which are used to group other dataset nodes or other data nodes. The edges also are kept to a minimum inside the core, being the contains edges. These edges are only used to show which data set contains which other data set or which other data node. And the lineage edge, which is used to display the development of the either data sets or data nodes. Both of these edges are unidirectional. In the case of the lineage, to show the chronological order. So the source is always the earlier version, the destination is always the newer version. And in the case of contains, it's unidirectional because to show the hierarchy, to see what nodes are contained within what other nodes. To separate more within the nodes themselves, the users can create subtypes, which are saved inside the type schema, which I shortly talked about before. And those subtypes can have any properties that the customer needs or wants. It's because the subtypes themselves don't have any direct effect on the API of the core. So for example, which I will show in the demo, the data nodes, we have CSV type, image type, and text type as subtypes for the data nodes. Let me change the screen to show the demonstration. Load there. There we go. Okay. I hope you can see the screen now. Like I said before, so if you imagine the use case normally would be that users, when they first create the system, they would create also the subtypes, which can be done within the type management itself, adding a new type, and then within the type, adding new properties. In the case of our example data here, sample data here, we have 6 types, CSV, image, and text for the data nodes, and report, simulation, and test for the dataset nodes. So inside the type management, we can create, edit, and delete different types and all their properties, which are then saved within the within the Oracle database. To manage the nodes and edges, we have the graph management page. Inside here, you can create and delete edges, data nodes, and dataset nodes. And another thing you can do is edit the dataset node and duplicate the dataset node. To explain, so let's say the dataset node subtype is, for example, simulation. If you, for example, Kaggle said in Toyota, so let's take an example for the car industry. You have a new prototype and you have multiple tests or simulations that you might want to run. So the duplicate dataset functionality is that you can select a simulation that you've done before and then create a new simulation dataset node with exactly the same. Or of course, if you want to change properties, you can just change it. If you want to have exactly the same simulation, but maybe one property is changed, then you don't have to write and insert everything from the beginning, but can just copy everything and change the things you want to change. What you can also do, since I was talking about uploading data before, uploading data is either within the create data screen or within the create data set. And of course, also later on in the edit or duplicate screen. So what you would do is you, for example, when you have a simulation, then you maybe get a few results screens. 1 second, I have to change to the, so I can drag and drop the images in. So, for example, I have a few files as a result from the simulation, so I drag and drop them in the file drop area, and then all the files that are dragged and dropped in are listed here. So within there, I can either have them sorted by name alphabetically, or in this case, by the extensions, which here is CSV, doc, and PNG files. And then we can choose which files we want to have and select the subtype, which of the data node which you want to apply it to. If we also see, oh, this file we don't really need it to don't want to upload it, we can also ignore it. And if we say, okay, we're finished, we don't need the rest of the files, we can also just close the upload file. And then you would see here inside the new data all the files that's been uploaded. So we try with that pop-up, we try to minimize having to upload files one by one and entering properties one by one. If as far as it's possible to group the different types of files, and if they have the same properties, then you can just have multiple files at once with the same properties of the subtype. But let's go to the visualization now. So this subtype, this visualization, we have within the user data saved default search conditions. In this case, it would be the dataset node and the subtype test. And so we only have in here a small sample data size, but here you can see that we have 3 dataset nodes of the type test. So if there wouldn't be any default values set, then of course it would be empty and nothing would be shown. When you want to search for specific nodes, either by node ID, which is unique, and you know the node ID, you can type in the node ID and search for the specific node, or you can go again, search by data, and then choose from the subtypes, or if you choose none, you get all the data nodes, or if you go data set, we had test before, if we go to simulation and search, then the simulation data nodes are shown. Like I said, in this case, it's for small sample data, just so that it's easily visible. What we can also do is change the X and Y scales. In this case, by default, X is the time and creation date, and created by is the user who made the node or who uploaded the data. And we can change this by the properties that are included within the nodes themselves. So, for example, we could change, we have time, and we could change to extra property or type, anything it can change, and then changes positions on the Y. But let's go back to the test datasets. When you click on here, you can see all the nodes that are included in the dataset node. The blue edges are lineage edges, and the gray white lines are contains edges. So we know that this dataset node contains this data node, and not the other ones, but the other ones are connected to this data node through lineage edges. So it's always the default setting is the 2 hops to have a bit more of a view, but of course that can also be changed. When we click right click, we can see, in case of a file, we would see file contents. If we click on the data sets, we just see the properties of the dataset node. And in the case of data, we can see data ID, data contents, and the properties too. If you want to, you can download that data if it's something that you need and you didn't upload yourself. But what's more interesting is the lineage view. So from the nodes, at the moment, we see here now, this is the node we selected before. If you remember the data ID, you can see it's the same one. So this data node is we want to see the lineage of this data node, so we get all the data nodes which are connected to it by one or more lineage edges. So in this example, what you can see is that even though, for example, this node here is not directly connected to the selected data node through an edge, that you can still see that they are connected through an ancestor which both of them share. So it might be interesting to see how these two nodes, how these two data nodes differ in properties and settings. That might be helpful for simulations or tests and see how they changed differently. So this is one way that the lineage view can help to find even more information and data that might not be necessarily visible directly if you just look at this node and its neighboring nodes. About what happens in the background within the graph data, the lineage, to visualize the lineage, we use an exist subquery. So basically we have a very simple normal edge select, and then edge select where exists the subquery, and the subquery being selecting all the all the nodes that are connected to the selected node by one or more edges. So in that way we get all of the nodes, and then from those nodes we select all the edges where those nodes are the destination. And for the search itself, we just use very simple everyday select nodes for nodes and edges that apply where the search conditions apply to. And now one more thing, let's go to the report page. Something that we thought might be useful is if you have multiple simulations, saved in different places, but you might want to combine them or compare two different CSV nodes and write comments for that. We added a screen where you can have from the subtypes, from the data nodes, you can search with different properties and then select them. And now let's just take from each one of them, image and text, and then within you can drag and drop those files so that you can see the contents. In this case, here's a text file which just says test. Here being an image file which you can move around and resize, and here being a CSV file. The core itself makes only parses CSV files, but of course in wrappers we can also have other files which then can be used to create graphs. In this case, either you can choose bar or scatter graph and then select which column of the CSV you want to display, and of course you can also resize. And then if you have all those data included, you might want to add a comment and also add custom text. So text inputs, in this case, you would just be running a comment. And then if you're happy with what you see and what you have, you can save the report. And later on, you can also edit it or delete. So basically manage the reports themselves. So that was the report is also saved within the object storage, which I've shown before in the structure. I guess this is the demonstration. Let me switch back to, where did it go? Let me switch back to the PowerPoint. Windows, okay. one more. PowerPoint. So yeah, so like I said, this is the core itself, and this has only the basic use cases, but based on whatever the customer or user wants, we could increase the number of edges, we could increase the number of nodes or any functionalities. What I've also heard before was a question about if it's possible to automatically farm the relationships or like data from external systems. And within the core, that's not possible, but it's definitely a thing that can be added inside a wrapper, depending on how accessible the external system is and how similar the relationships are there. What I forgot to do in the beginning, to introduce myself, like I said, my name is Dominik Junkermann. I'm chief developer here at Kagla. Kagla is based in Toyota City, and we're happy to be an Oracle partner. Something unique about Kagla as an IT company, in my opinion, is that 80% of our full-time employees are female, and that half of them are working inside the development team. And yes, as you can see on the right side, we are still hiring. So if you have any interest in Trinity or questions about Trinity, feel free to write me at dominik@kagla.jp, or if you feel interested to work with us. That would be it from my side. I don't know, we have to see if there are any questions. And but otherwise, that would be it from my side.
Okay, let's wait a couple seconds to see if there's any questions. In the meantime, thank you so much, Dominik and Ryota, to take the time to share the graph technology with all the community in the Asia Pac and globally. And also, this session is recorded, and the playback will be available to everyone that's registered to the conference until 30th of December. Basically, the people that need to register to the session, even if they already passed the live, and then the playback option will be showing on their attendees page on their personal calendar to watch the session at any time they want it. If you're watching the recording and you have any questions to Dominik and Ryota, please feel free to contact them to their emails directly or through their Twitter handle. You can contact them by Twitter. And also, if you cannot find them, you can contact us with Apaca UC, and we can relay your questions to Dominik and Ryota. And it looks like it's no question live. The people is very shy, looks like at this time of the day. And in that case, thank you so much, Dominik. Thank you so much, Ryota, for your time. And please take care and be safe on these pandemic times.
Thank you.
Thank you, Francisco.
Have a wonderful day, afternoon or evening, depending on where you are around the world.
Yep, you too.
You too. Bye-bye.
Thank you.
Bye.
Bye-bye.
CloudDB, shaping your new normal.